So what if your company was just hemorrhaging money, millions of dollars, and you didn't even really know precisely why? Well, that was the tough reality for the online retailer ShopSmart. In this explainer, we're going to dive right into their story and see how building a solid data foundation was the absolute first, most critical step in solving a multi-million-dollar crisis. Okay, let's just start with the number that got everyone's attention. $7.5 million. Just let that sink in for a second. This wasn't profit. This wasn't revenue. This was the sound of money walking right out the door year after year. So, where was all this money going? What was causing this massive leak? Well, the answer was kind of simple, but totally devastating. They had no reliable way of knowing which of their customers were about to leave, to just walk out that digital door and take their business somewhere else. But you can't just slap a machine learning model on a problem like this. Nope. Before they could even dream of building some fancy prediction engine, they had to confront a much deeper, much messier problem: the chaotic, completely manual state of their data. It was a nightmare. And this before and after, wow, it tells a story about the real human cost of bad data. I mean, can you imagine spending a full work week that's 40 hours every single month just wrestling with spreadsheets? That was the reality for their analysts. They were totally trapped, just constantly reacting to old data, instead of proactively finding the insights that could actually save the business. Yeah, this old system was pretty much a recipe for disaster. You had the marketing team basically lighting money on fire, targeting customers who were already happy, while the ones who were at risk just slipped right through the cracks. Every decision was reactive, based on data that was weeks old. And maybe the worst part of all, nobody, and I mean nobody, trusted the numbers. So, to fix this, ShopSmart knew they had to stop just bailing water and actually start building a proper ship. They realized what they needed was a fully automated assembly line for their data. So how'd they free up their analysts? They built this really elegant three-step pipeline. And here's the best part. Every single morning at 2 a.m., while everyone was asleep, the system did all the heavy lifting. It extracted the raw data from all its different sources, it validated that data to make sure it was clean, and then it versioned it to create a perfect historical record. So, by the time the team logged in on the morning, fresh, reliable data was just waiting for them. And you gotta understand, getting a complete picture of a customer was incredibly complex. They had to pull together what they called these raw atoms of data from 4 totally different places: their main customer database, their transaction history, these messy behavior logs from the app, and even by digging into customer support conversations through the Zendesk API. All of that had to come together.
All right, so automating the data flow is one thing, but it's not enough, not even close. For any serious machine learning system, you have to be able to trust that data, like 100%. And you need the ability to travel back through its history.
To build that absolute trust, ShopSmart basically hired a bouncer for their data pipeline. They set up these automated checkpoints, these quality gates, to scrutinize every single piece of data coming through. And they used a really popular tool for this called Great Expectations. And these checks acted just like a bouncer. Is a customer ID missing? Is a price showing up as like a negative number? Is the data from yesterday or is it stale from last month? If any rule gets broken, the bad data is immediately rejected and an alert goes out. This prevents that corrupted information from ever poisoning their models. It's so smart. Okay, next up, for that historical record, they implemented what is essentially a time machine for their data. They used a system called DVC, which, as you might guess, stands for Data Version Control. In this quote right here, just nails it. Think of it as Git for data. It brings the same kind of discipline and rigor to managing data that software engineers have used forever to manage their code with Git. Every single change gets tracked, creating this perfect auditable history of the data over time. So a data time machine sounds cool and all, but why? Why does having this perfect, time-traveling history of your data actually matter to the business? Because this isn't just some neat tech feature. It has massive, real-world implications. It really all comes down to these 4 pillars. If a regulator comes knocking and asks you to prove what data trained a model 6 months ago, you can do it. If a model suddenly goes haywire, you can pinpoint the exact data change that caused it. And if a bad data update somehow gets pushed through, you can instantly hit rewind. It's your safety net, your audit trail, and your undo button all rolled into one. So, after all this hard work, after building this rock-solid foundation, what was the real-world payoff? Did it actually work? The results were, well, they were immediate and totally transformative. Remember those 40 hours of manual analysis every month? Poof, gone. Data delivery went from being unpredictable and slow to a reliable daily thing you could set your watch to. And they saved over $20,000 a year in analyst time alone, and that's just in this first stage.
But look, the biggest win wasn't the time or the money. The real win was establishing a bedrock of absolute trust in their data. You've heard the saying, right? You can't build a skyscraper on a swamp. Without trusted data, you're just building on sand. But with it? Well, with it, every other stage of machine learning suddenly becomes possible.
And all of this leaves us with one final, pretty provocative thought. ShopSmart built a perfect data foundation, a pristine pipeline they could trust. But that only solves half the problem. The next challenge is, what do you do when the model itself starts to drift? How do you manage its life cycle, its performance, and its inevitable decay? We'll explore that next time.